Hello, my name is José Ortiz Farías, and this is my asynchronous activity number 8. The three activities we'll be talking about will be freefall, vertical launch, and a horizontal launch. Now, let's begin. You're a detective and find a note with a body. This person fell from very high. After 11.2 seconds, he said to this world, bye. Guess from which building I dropped him off? This game will be very rough. Now, with the given information of 11.2 seconds of the fall, we have to calculate the height of the building and the final velocity before hitting the ground. With this, we will use the position formula, which will be y equals the initial velocity times time plus 1/2 g, which is positive in this problem, and t squared. Now, we know that in the rules of freefall, initial velocity is equal to 0. So this term cancels out. Now, we get that y equals 1/2 g time squared. We replace the information, which is y equals 1/2. G is 9.8 meters per second squared. We replace that. And we also have to multiply by time, which is 11.2 seconds. And don't forget to square it. Now, we input this in the calculator. And we calculate that the height of the building must be 614.65 meters high. And to calculate the final velocity before hitting the ground, we can use the following formula. 2 times g y equals the final velocity squared minus the initial velocity squared. Now we have to isolate the terms, and we know that initial velocity is 0, so this can cancel out. So final velocity is squared. We replace it by putting 2 times 9.8, which is g, times the height of the building, which is 614.65 meters. And we don't forget to take the square root of this operation. We input this in our calculators. And we get that the final velocity before hitting the ground was 609.75 meters per second squared. Meters per second. We now have to go and calculate and find the building that meets this criteria. Now, once we have found the building, we notice that it's the Clover building, an office building in the city. We get to the rooftop and we find a second note. Well done, Mr. Detective. Of physics, you seem to be knowing. But let's keep playing and playing. From the ground, I shot up a ball, double the height of the building. It fell exactly on the roof after we don't know how many seconds. The time is my cubicle, round to the nearest integer, and the initial velocity is my password. Now we have to imagine that he shot up a ball from all the way down here with some kind of cannon. And we have to calculate, remember that it's double the height of the building, and then it fell down onto the roof of the building. Now, we know the height of the building, which was 614.65. Now, this height, we have to double it in this part. So let's take this And this part of the problem is 614.65 times 2, which is 1,000. One moment. Which is 1,229.3 seconds. 3 meters. And now, since it's from double the height, the second part of the problem, this one right here, we know that this is just one height of the building before falling onto the roof. So this part will be the height of the building, which is 614.65 meters. Now, what is the initial velocity? We can calculate this by using the following formula. 2g y is equal to final velocity squared minus initial velocity squared. Now, we're going to use this in the first part of the problem until it reaches the top here. We know that when it reaches the top, the final velocity is 0. So this can cancel out. Now we have to do this so that we have to isolate so that the initial velocity gives us a positive outcome. So this will be the formula. Now we have to replace with the information that we already have, which is the height and the gravitational pull. In this problem, the gravitational pull is going to be negative since it's fighting against us launching the ball. So we replace this in the formula, minus 2 times g, which is minus 9.8 meters squared. And this times y, which is 1,229.3 meters. And this is a squared, so we have to get the square root of this. Don't forget. We input this in our calculators. Just double checking that everything's all right. And we get that the initial velocity is 155.22 meters per second squared. Meters per second, excuse me. Now, what is the time it took the ball to reach the roof? We have to calculate now the time it takes this ball to get to double the height of the building and how it takes to fall down onto the building. Now, the time, we have to calculate this using the initial velocity. We can do this by using the time formula, which is time equals to final velocity minus initial velocity over acceleration, which is g this time. Now we have to remember that final velocity here in the first part is 0 minus the initial velocity, which was 155.22. Now over this, we have to put the gravitational pull, which is negative. Remember, in this problem, the gravitational pull is negative. Now we have to input this in our calculators. And gives us that the time is 15.83 seconds. Now, let's not forget that this is just half the problem. We have to also remember how long it takes to fall. But we already have that in the past problem that we calculated that it falls one height of the building in 11.2 seconds. Remember? So we have to add this 11.2 seconds. Now, just add that. And we get that the answer is 27.03 seconds. Now we can go and search for the murderer's cubicle. Now, once we found the cubicle number 27 and input the password 155.52.22, we found that it only contains a single document. And it reads, "Man, you're so good, you might catch me. From this height of the building, 400 meters, I send the next clue to a nearby building at initial speed of 30 meters per second. On its sixth floor, you will find it. You will have to guess the building." Now, we know that one floor is around 4 meters. So we have to calculate how far the ball reached, how far is the other building, and what is the total distance the ball reached. Now, we know that it's on the 6th floor of the other building. So this is the 6th floor. And now the height of the 6th floor will be this height times 6, which is, let me just get that right, which is 24 meters. So this will be 24 meters. With that, we can also calculate the height it dropped from here, because we know the height of which we was launched, which was 400 meters. We just have to find the difference between these two, which is 360 360 and 76. 376. With this, we can also calculate the time it took to fall, so we can calculate the distance it took from its speed on the x-axis. So with this, we can use the formula time equals the square root of, let me just do it somewhere else, because time equals the square root of 2y over g. Now this g will be a positive in this one. So with time over y, which is this, 376 over 9.8. With this, we input it in our calculators. And we get that the time it took to fall down was 8.75 seconds. Using this, we can also calculate the distance, the horizontal one, with the 30 meters per second. We just have to multiply 30 times 875, since the horizontal distance doesn't change. And that is 30 times 8.75. And that will be a distance of 262.5 meters. This is the distance from the building 1, which is a Clover building, into the other one, to the other building, we don't know. So we have the answer of the first one. It's 62, forgive me, 0.5 meters. Now, what is the total distance the ball followed? We can calculate this by using the following formula. Using this formula, we use, sorry, this was a typo. The total velocity the ball gained. This was a typo, forgive me. So we can use this by using the following formula. V equals the square root of the velocity, the final velocity on x squared, plus the final velocity on y squared. Now we know the first one, which is 30, plus we have to get the second value. Now we know it took 8.875 seconds to record this. So we can use the following formula. We can use the time equals final velocity minus initial velocity over g, but this time we have to isolate final velocity. We go this times this, and initial velocity, and now we get that time times gravity plus initial velocity equals final velocity, which we remember that initial velocity in the y-axis is 0. So this one we can cancel out, and it's just time, which is 8.75 seconds, 8.75 seconds, times the gravity, which is, we remember, 9.8, and it's positive in this problem. And now we only have to multiply 0.875 times 9.8, and we get that the final velocity on the y-axis was 85.75 meters per second. Now we input this in the formula, 85.75, and now we get that the final velocity is the square root of 30 squared plus 85.75 squared, and the square root of that, and we get that the final velocity was 90.84 meters per second. Thank you very much, and this was my asynchronous activity. Thank you.